we are going to discuss dimensional analysis. What are the applications of dimensional analysis? What are the limitations of dimensional analysis? This all we will discuss here. First, we will see how to write the dimension of a physical quantity. For that, we should know what are the dimensions of fundamental quantities. You know which all are the fundamental quantities: length, mass, time, electrical current, thermodynamic temperature, amount of substance, and luminous intensity. What is the dimension of these all fundamental quantities? For length it is L, time capital T, mass capital M, electrical current I, thermodynamic temperature theta, amount of substance N, luminous intensity it is J. So these all are the dimensions of fundamental quantities. Then you know what is meant by derived quantity. Derived quantity is derived from the fundamental quantity. So when we want to write the dimension of a derived quantity, we will express this derived quantity in the powers of these fundamental quantities. So what is meant by dimension? Dimension of a physical quantity are the powers to which the fundamental quantities are to be raised to represent that physical quantity. That means you know the dimension of length, it is capital L. Then what is area? Area means side into side. That means length into length. So dimension of area is L raised to 2. Same way, volume. Volume means side into side into side. LBH, you know it. But all the sides dimension is capital L only because that is length. Then what is the dimension of volume? Volume dimension is L to the power 3. That is why it is told the dimension of a physical quantity is expressed in the powers of fundamental quantities. Next, dimensional formula. What is dimensional formula? Dimensional formula is the expression which shows that which of the fundamental quantities and with what powers enter into the derived unit of physical quantity is known as dimensional formula of a physical quantity. Say, suppose we are writing the dimension of area. Simply if you write L square, it is wrong. We have to show mass and time there. But mass, the power is 0, and time, the power is 0. Because in the area, mass and time content is not there. But when you write the dimensional formula, we have to express the fundamental quantities, that mass, length and time in mechanics. Now, what is meant by dimensional equation? The equation obtained by equating the symbol of a physical quantity with a dimensional formula is called dimensional equation. Here, say the square bracket. Within the square bracket, I wrote it A. That means dimension of area is equal to m raised to 0 L square t raised to 0. If we write this way, it is dimensional equation. We are equating the physical quantity with the dimensional formula, then it becomes dimensional equation. Now, principle of homogeneity. When we write this equation, you know that dimension of the fundamental quantities of two sides of a physical relation must be same. When I write here area, the dimension of area that is same as this. So if you write that way, we can write m raised to a, l raised to b, t raised to c is equal to m raised to x, l raised to y, t raised to z. That means these two formulas same. Base is same, so you can equate the powers of same base. That means a is equal to x, b is equal to y, and c is equal to z. Here the dimension of few physical quantities given. You know that area. Area means length into length. Already I told you L into L, that is L square. Volume. Area into length. That means L square into L, L cube. That is dimensional equation is this one, m raised to 0, L cube, t raised to 0. Then density. What is the equation of density? All of you know it. Mass upon volume. The dimension of mass is m. The dimension of volume is L cube. So when we will write the equation m upon L cube, then again we rearrange m L minus 3. So when we write the dimensional formula, m raised to 1, L raised to minus 3, and t raised to 0. The same way, speed and velocity. Speed or velocity, physical quantity we are telling it different, but dimensionally both are same only. Distance upon time, that is this one. Same acceleration, velocity upon time. Linear momentum. Momentum means P is equal to mv, mass into velocity, you know it. So mass dimension is m, velocity it is L t minus 1. So we combined it, we got the dimensional formula here. Then force, mass into acceleration. So from the equation of the derived quantity, we can write the dimension of any physical quantity. If you know the formula of that physical quantity, you know work say force into distance, force into displacement. So force dimension, you know it because already we discussed here, into distance. Then energy mgh, but you know that dimensionally work, energy same only. Then potential energy is there, kinetic energy is there, so all the dimension it will be same only. Now we will discuss what are the different types of variables and constants. What is meant by dimensional variable? The physical quantities which possess dimensions and have variable values are called dimensional variable. That means most of the physical quantity, length, mass, time, then area, then volume, density, these all are dimensional variables only. Which all are the dimensions we are usually discussing? These all are dimensional variables only. Velocity, acceleration, force, these all are dimensional variables. Why? Because you know that its value always change. We know that force 2 Newton, 3 Newton, that means its value always change. Physical quantity which possess dimension, it is having dimension, but its value always changes. That type of physical quantities are called dimensional variables. What is dimensionless variables? The physical quantities which have no dimension but have variable values are called dimensionless variables. Dimensionless variable because it doesn't have a dimension. You know that angle theta, it is the ratio of arc length upon radius. Arc length upon radius means arc length is also having the dimensional, radius also having the dimensional, both will divided, so it become dimensionless. The same way trigonometric ratios. Trigonometric ratios means sin theta, cos theta. This all it is dimensionless, but its value vary. Different situation, its values are different. Same way relative density. Relative density or specific gravity. That is also a ratio. And what is meant by relative density? that is density of a substance upon density of water. So it is also a ratio in terms of density. So it is also dimensionless. Dimensional constant. Few quantities which have a dimension but they are constant. Speed of light in vacuum. You know it, 3 into 10 to the power 8 meter per second. We are usually saying. Its value is constant but it is having dimension. The same way, gravitational constant, capital G. Then Planck's constant. These all have a dimension but its value is constant. They are called dimensional constants. Then dimensionless constant. The quantities which do not have dimension but have constant value are called dimensional constants. All numbers 1, 2, 3. Then the value of pi 3.14 e. These all are dimensionless constants.